Meet Ganymede, the largest moon in our solar system. At first glance, it seems like a desolate, frozen world, scarred by craters and ancient ice. But beneath this frigid, quiet shell, it's hiding a secret so big it could change everything we think we know about life in the universe. Ganymede is a water world, home to an ocean so vast it likely contains more water than all of Earth's oceans combined. And that's not science fiction. For decades, we've been gathering clues, piecing together a puzzle scattered across hundreds of millions of kilometers. The story of this discovery is a testament to human ingenuity, a cosmic detective case solved with glimpses of light and invisible forces. This is the story of how we uncovered this hidden sea and the race to find out what lies within its dark, mysterious depths. The king of moons. To really get Ganymede, you have to start with its incredible size. When Galileo Galilei first pointed his simple telescope toward Jupiter in 1610, he saw 4 points of light dancing around the giant planet. The third and brightest of these was Ganymede. He couldn't have known it then, but he had just discovered the king of all moons. Ganymede isn't just Jupiter's largest moon, it's the largest in our entire solar system. Let's put that in perspective. With a diameter of over 5,200 kilometers, Ganymede is bigger than the planet Mercury and the dwarf planet Pluto. If it broke free from Jupiter's grasp and orbited the Sun on its own, we wouldn't call it a moon at all. We'd call it a planet. But here's the first clue in our mystery. Despite its immense size, Ganymede is surprisingly light. Its density suggests it's made of roughly equal parts rock and water ice. This tells us that Ganymede is fundamentally different from rocky inner worlds like Earth or Mars. It's a world born from the colder, icier outer solar system. It orbits Jupiter at a distance of just over 1 million kilometers, circling the planet every 7 days. Like our own moon, it's tidally locked, so the same face is always pointing toward its massive host. But Ganymede isn't alone. It's locked in a delicate gravitational rhythm with its neighbors, Europa and Io, in what's known as a Laplace resonance. For every one orbit Ganymede completes, Europa completes 2, and Io completes 4. This cosmic metronome isn't just a neat coincidence, it's a critical piece of the puzzle. The constant, rhythmic pulling from its siblings and parent planet has shaped Ganymede's history, generating forces that have sculpted its surface and, as we'll see, churned its very heart. A tale of two surfaces. We got our first real close-up of Ganymede not from a telescope, but from the robotic eyes of spacecraft. The twin Voyager probes in 1979, NASA's Galileo orbiter in the 1990s, and more recently, the Juno mission, gave us our first detailed look. What they revealed was a world with a split personality, a surface divided into two dramatically different terrains. About a third of Ganymede is covered in dark, ancient regions saturated with impact craters. These areas, like the vast Galileo Regio, are a record of a violent past, a surface that has stayed mostly unchanged for up to 4 billion years. They're like ancient, weathered continents, telling a story of age and endurance. But it's the other two-thirds of the surface that really captures the imagination. Slicing through the dark terrain are vast networks of brighter, younger ground covered in complex patterns of parallel ridges and valleys called grooves. This grooved terrain looks as if the moon's crust has been stretched, pulled apart, and resurfaced. This discovery was stunning. It was the first clear sign that Ganymede wasn't just a dead ball of ice and rock. The grooved terrain was evidence of immense geological activity. Something profound had happened in Ganymede's past to break and reform the surface from within. The leading theory is tectonism, where the icy crust was stretched and fractured. But what could provide the energy for such a massive reshaping? What could cause a frozen world to tear itself apart? The clues all pointed in one direction, down. The central mystery, a phantom ocean, and this is where the real detective work begins. The images from Voyager and Galileo were compelling, but they were just pictures of the surface. How could we prove what lay beneath? Ganymede's surface is one of the coldest places in the solar system, with temperatures dropping to -200 degrees Celsius or -330 degrees Fahrenheit. The idea of a liquid water ocean hiding under a crust of ice thought to be 150 kilometers thick seemed almost impossible. It posed a tantalizing question: how can scientists be so sure about this massive ocean if we can't see it? How do you peer through 100 miles of solid ice on a moon 500 million miles away? The answer isn't a drill or a camera, but the invisible forces that shape the cosmos. The clues were found not in what we could see, but in what we could measure: magnetism and light. Ganymede was broadcasting its secret across the solar system. We just had to learn how to listen. The puzzle was solved in 2 brilliant steps, with 2 different discoveries years apart that perfectly backed each other up. The telltale clues: the first monumental clue came from the Galileo spacecraft as it flew past Ganymede in 1996. Its instruments detected something utterly astonishing: Ganymede has its own magnetic field. To this day, it's the only moon in our solar system known to have one. Planets like Earth generate a magnetic field from a churning, liquid iron core. The discovery that Ganymede had its own field strongly implied it also had a liquid metallic core, making it behave like a miniature planet. That discovery changed everything, but it was only the first step. Ganymede's personal magnetic field is tiny compared to the colossal magnetic field of Jupiter, which completely engulfs the Moon. This constant interaction is where the second part of the clue lies. Scientists realized that as Jupiter's massive magnetic field sweeps past, it should create a secondary, induced magnetic field in any conductive material inside Ganymede. Think of it like a cosmic metal detector. Solid ice is a poor conductor, but a huge layer of salty liquid water would be an excellent one. When Galileo measured Ganymede's magnetic environment, it found 2 fields: the Moon's own from its core, and another fluctuating field that perfectly matched predictions for an induced field from a subsurface saltwater ocean. It was our first real piece of evidence, a magnetic echo pointing to a hidden ocean. But science needs more than one piece of evidence. The smoking gun came years later, not from a spacecraft near Jupiter, but from the Hubble Space Telescope, observing from right here in Earth's orbit. A team of scientists devised a brilliant new way to probe Ganymede's interior by watching its auroras. Just like on Earth, Ganymede's magnetic field channels charged particles to its poles, creating shimmering ribbons of light. Because Ganymede is inside Jupiter's magnetic field, as the giant planet rotates, its magnetic field causes the auroras to rock back and forth. Scientists calculated that if Ganymede were frozen solid, its auroras should rock by about 6 degrees. For over 7 hours, Hubble stared at Ganymede, watching the faint ultraviolet glow. What it saw was astounding. The auroras were rocking, but only by 2 degrees, not 6. Something was pushing back, resisting Jupiter's magnetic pull. That something was the hidden ocean. The induced magnetic field created within the salty, conductive water was generating a kind of magnetic friction, damping the rocking of the auroras. The observation was undeniable. It was the final, irrefutable piece of the puzzle. Ganymede was hiding an ocean. A recent analysis from the Juno mission in 2021 has further supported these findings, detecting salts and organic compounds on the surface that were likely deposited from the ocean below. Why it changes everything, confirming Ganymede's ocean was just the beginning. The implications are staggering. First, there's the sheer scale. The ocean is estimated to be about 100 kilometers deep, 10 times deeper than Earth's oceans, buried under a 150-kilometer thick crust of ice. In total, this single moon is thought to hold more water than all of Earth's surface water combined. What's more, computer models suggest the interior isn't a simple ice-ocean rock structure. Under the immense pressures inside Ganymede, water can form different, denser phases of ice. This means the interior could be a complex, club sandwich, of alternating layers of ice and liquid water. Crucially, these models suggest the lowest liquid layer may be in direct contact with a rocky mantle. And that is the key. This water-rock interaction opens up one of the most exciting possibilities in science: the potential for life. For life as we know it, you need three key ingredients: liquid water, essential chemical elements, and an energy source. Ganymede clearly has the water. The chemical building blocks, like organic molecules, are believed to be there, delivered by comets and present in the rock. That leaves the final ingredient: energy. Here on Earth, most life relies on the sun. But deep in our oceans, far from sunlight, entire ecosystems thrive around hydrothermal vents, cracks in the seafloor where geothermally heated, mineral-rich water erupts. On Ganymede, the energy source isn't the sun, it's gravity. The same tidal forces from Jupiter and its neighboring moons that fractured Ganymede's surface also constantly knead its interior. This process, called tidal heating, generates enough warmth to keep the vast ocean from freezing solid. This internal heat could power hydrothermal vents on Ganymede's seafloor, creating the exact kind of environment that supports life in Earth's deep oceans. This discovery fundamentally redefines the habitable zone. We used to think life could only exist on planets at a Goldilocks distance from their star. Ganymede proves this idea is too narrow. It shows that even on a frozen moon far from the sun's warmth, gravity can create vast, potentially life-sustaining oceans. This means the number of habitable worlds in our galaxy could be far greater than we ever imagined. The search for life is no longer confined to Earth-like planets, it has expanded to the hidden oceans of icy moons. The quest continues. We've learned so much from quick glances and clever deductions, but the biggest chapter in Ganymede's story is just getting started. We've never had a dedicated mission to study this ocean world up close. That's about to change. Launched in April 2023, the European Space Agency's Jupiter Icy Moons Explorer, or JUICE, is on an ambitious journey to the Jovian system. Right now, in March 2026, it is weaving its way through the inner solar system, using gravity assists from Earth and Venus to build up the speed needed for its long flight to Jupiter. JUICE is carrying a powerful suite of 10 instruments designed to investigate Jupiter and its three largest icy moons: Europa, Callisto, and especially Ganymede. After arriving at Jupiter in 2031, it will perform dozens of flybys. But its grand finale is what makes the mission truly historic. In late 2034, JUICE will do something no spacecraft has ever done. It will enter into orbit around another planet's moon. For months, JUICE will circle Ganymede, mapping its surface in incredible detail. It will use a powerful ice-penetrating radar called RIME to beam radio waves through the crust, hoping to directly measure the ocean's depth. It will study Ganymede's mysterious magnetic field, analyze its thin oxygen atmosphere, and search for signs that water from the ocean may have erupted onto the surface. Now, JUICE isn't a life-finding mission. It doesn't have the tools to detect living organisms. But its job is to characterize Ganymede's ocean, measure its properties, and determine if it truly is a habitable environment. It will transform our understanding of this world from a place of strong evidence to a place of hard facts. From a faint point of light in Galileo's telescope to a world we now know holds an ocean larger than all of our own, Ganymede has completely transformed our understanding of the solar system. It's a world of superlatives: the largest moon, the only one with a magnetic field, and the holder of the greatest ocean we know of beyond Earth. It's a powerful reminder that the universe is packed with surprises, and that some of its greatest secrets may lie hidden beneath the most unassuming surfaces. We stand on the precipice of a new era of discovery, waiting for a robotic explorer to finally arrive and pull back the curtain on this mysterious water world. The answers to some of our oldest questions, are we alone, and where else could life exist, might just be waiting for us in the dark, silent ocean of Ganymede. The story of Ganymede is still being written, and with missions like JUICE, we know the most exciting chapters are yet to come. If you want to follow that journey and continue exploring the greatest mysteries of our cosmos, make sure you subscribe and hit the notification bell. Thank you for watching.